Going live. Going live. um, Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 44, Securing Identity and Context in Microservices. Our guest today is Atul T, co-founder and CTO of Signal. That's SGNL Signal, not the messaging app. Welcome, Atul.
Hi, thanks for having me. Great to be here.
And Atul, before we dive into transaction tokens and microservices, maybe you could just tell us a little bit about yourself.
Sure. I guess I started my career as a supercomputer scientist in India, right? So I was working on India's first supercomputer, and the supercomputing business has had its challenges, right? So we were successful to begin with, but soon enough we were unable to sort of meet the challenges of the killer micros, right? The microprocessors which were getting like much faster, and we couldn't keep up. So around that time, I was trying to figure out what to do next, and I got into cryptography just because I love the idea of being able to prove yourself on the internet without actually being face to face, right? And so that's how I got into this area, right? And so I took up a job. I'm skipping a few steps in between, but I took up a job at a really early stage startup in the Bay Area called VeriSign. And we obviously what VeriSign is, and for those who don't know, we were sort of laying down the foundation of the security on the internet as we see it today, like the TLS certificates and the standards, and all the certificate authority and all those things. We kind of shaped that whole area back then when we were at VeriSign, and so it kind of led to its logical sort of next step, which is you know people are not going to use certificates on their end user desktops, right? At that time it was just desktops, and so we decided that okay, we need some way to communicate your identity securely without having to completely rely just on your username and passwords. And that's how we sort of came up with federated identity. And obviously I didn't invent any of this. This was just sort of, I was just a part of a group called the Liberty Alliance, and that's how sort of this federated identity thing came about. And then we contributed all that, and that standard now became SAML 2.0, which is sort of very popular these days, right? And so I took a little bit of a break from identity after that, but then I realized that identity is really what drives me. And then I became an architect at a company called Mobile Iron, and then at Google. Right in between, I had started my own company that was acquired by HP, that was a federated identity startup. So yeah, have had a very close relationship with identity for well over 15 years now.
All right, and I'll get to the final chapter, which is Signal, but we'll talk about that a little bit in a second. Let's dive into the topic today, which is about transaction tokens. And in about 10 episodes, we had an episode 34 with Peter Castleman and Evan Gilman, and we talked about Spiffy and Spire. And I'd actually like to share a diagram that you shared with me previously. Let's see how this works. Yeah. And maybe you could walk us through why do we need transaction tokens, and why wasn't Spiffy enough?
Yeah, yeah, and that's great because Peter is one of the co-authors of the spec with me. So what Spiffy does is essentially gives you a great way to assure trust between services. So with Spiffy, you can know exactly which service is calling you, right? And then also makes it possible for you to call other services securely, so that there is a trust established between your service and the target service. Now, there are a few attacks that are possible that, which makes this not sufficient. So it is kind of an important underlying layer, but it's not sufficient, because what can happen is that, through a software supply chain kind of attack, or through a privileged user compromise, one of the services in your infrastructure might get compromised, right? One or few, right? And then if that service can assume the identity if the attacker can assume the identity of that service, they can basically just call you and tell you to do something that you're not supposed to, right? For example, instead of the legitimate user saying, I want to buy 100 shares of Microsoft, the service might tell you, hey, it's like this other user and they want to sell 1,000 shares of Google, right? So it can completely change the whole. It's almost like having remote code execution within your VPC, and these are the kinds of attacks that are extremely hard to detect, because everything just appears like it's normally working, but things are not actually happening the way they're supposed to be, right? So what you then need is the assurance that, well, is it exactly the same user that is in play, that on behalf of whom the internal services are making their calls? And so, as you can imagine, like what happens in a VPC, the external invocation comes into an API gateway of sorts, and from there you have a call chain that spans a lot of microservices, right? And so what you have to make sure is that the original intent of the call, right, the original user, the original context of that call can be preserved throughout this call chain, right? And so any service in between should not be able to make spurious calls that have nothing to do with the original intent of the incoming call in order to do their actions, right? And so that is what is assured by transaction services. So as you can see in this diagram, you get some security with Spiffy, but what you get more of, that you kind of make it really hard for anyone to change anything about the original intent of the call and the identity of the caller throughout your call chain, right? So what happened was, I was used to having a secure environment in microservices in Google, and then when we sort of branched off of Google, and Eric Gustafson and I were talking to many people and saying, hey, what is an open source way of doing this, right, in out there, right? And we realized that there was nothing there, and then we sort of found out when we talked to people at other major technology companies that everybody had a way of doing this. It was following a similar pattern, but there was no standardization. So that's how George Fletcher of Capital One, who had actually independently thought of the transaction tokens term, is actually his idea, and sort of he had made an excellent presentation in Identiverse about transaction tokens. And Peter Castleman and I, who were sort of talking about this separately, we all got together and said, let's make this into a spec. And so we created the transaction token spec that then can assure user trust and assured context in sort of a short-lived JOT, like JSON Web Token, that then cannot be altered by any of the services in your call chain. Right? So that's what transaction tokens are in a nutshell.
Do you think it would be incorrect to say that the layer where you're saying we're here, the implicit trust and the service trust, that's layer 3, and that user trust and assured context is layer 4? Is that a loose analogy, sort of like maybe true?
So, I don't have the same kind of OSI stack familiarity that people have, and so I'm going to guess that that's kind of true. But don't hold me to it. I might
I'm
get the
showing my
analogy
age a
wrong,
little
right?
bit.
Yeah, yeah.
I started an ISP back in the 90s, and I still think about like layer 2 and layer 3 and layer 1, and
Yeah.
but to me it seems like an apt way. This service to service trust. It's MTLS plus a little bit, because Spiffy has a special way that they use certificates to convey more information. But I think it's really about the services sort of making calls securely to one another.
Yep.
But when you get into user trust in a short context, I think that's going a little bit deeper into things that the transport layer really has no idea about. Like you gave the example of like buy 100 shares of Google at this price, or who even is this user? That's something that I think is not really apparent. Okay, let me stop the screen sharing. Um, and so to obtain a transaction token, the application uses a profile of the token exchange, but client authentication is sort of outside the scope of the transaction token. What are your thoughts on a typical way that a client might obtain a transaction token?
Right. So one of the things that the transaction token draft defines is the notion of a transaction token service, right? A service that can mint transaction
Or an
tokens, and
endpoint,
it,
let's say.
right, right, and that's your sort of token exchange endpoint. And the public key of that transaction token service is known to all the services, so they can all verify that something that is being signed by that transaction token service is indeed from that transaction
Mhm.
token. And so, what the transaction token service can do is it can restrict who can call it, right? And so it relies on the service to service trust, like Spiffy, to make sure that it can restrict which are the services that are allowed to, in fact, invoke the token exchange endpoint, right?
Mhm.
That it provides. Now, you can, in a real world situation, just restrict that to your API gateway, right? And your API gateway might be your sort of, Azure APM if you're in Azure, or if it can be Google Apigee, or it can be, AWS API gateway, or, you might use a third party gateway like Kong or MuleSoft or something like that, right? And so, as long as you can keep that API gateway secure, you are able to then assure, using Spiffy or using MTLS, you can assure that identity of the caller to the transaction token service, and that's how you make sure that nobody else can sort of mint a token, that can pretty much give them anything that they want.
Right. Oh, I misspoke a little bit. Actually, the transaction token doesn't have an endpoint specific to it because it's using the token exchange, but you actually profiled token exchange to say, here are some reserved and optional parameters that you use in order to invoke this, which is kind of nice because you didn't actually have to define any new endpoint in order to make this happen.
Yeah,
Um,
there was a good bit of debate on whether we should have our own endpoint or whether it should just be the transaction, the token exchange endpoint. And it sort of token exchange seemed to do what we wanted to do, and so that's how we ended up using it. It wasn't like we started out by saying let's do token exchange. It was more like we need this something that will get us the transaction token based on the context of the incoming call.
Right. So the authentication scope or authentication being out of scope means that potentially a client could use private key authentication and present maybe a token. So you're leaving some room open for some ways to obtain a token other than Spiffy or MTLS.
Yeah, I mean, exactly. I mean, you can choose the way you want to authenticate the requester to the transaction token service.
So there's another RFC called OAuth RAR, or Rich Authorization Requests. It's RFC 9396, which says you need to determine how the authorization details, which are sent in a parameter with that same name, are reflected in an access token or introspection response. So I always saw OAuth RAR sort of as predating transaction tokens because OAuth RAR says you can make a request and include these authorization details, but I'm not going to tell you what's in those details. Do you think, am I onto something, or is that, am I imagining?
No, no, absolutely. It's definitely a way to mint tokens like transaction tokens that you might use for securing call chains. The difference between RAR and transaction tokens, a couple of things, right? First of all, we don't expect the transaction token service to be the same as your OAuth server, right? Authorization server, right? So it could be a completely different service that, as a part of its input context, receives an OAuth token that is coming to you, but it doesn't have to. And the second thing it does is it has a lot of responsibility of its own, right? So whereas in RAR, you're actually specifying what you want in the token, right? In transaction tokens, you're just providing the context to the transaction token service, and the transaction token service is actually determining what should be inside the tokens, right? And then the other property is that the transaction token service is always going to mint like super short-lived tokens so that they cannot be replayed afterwards. And so those are some ways in which like RAR and transaction tokens differ.
Now, you're saying that the transaction token service would be possibly outside of your OAuth authorization server, but your OAuth authorization server is already doing a lot of the same stuff. It's signing JWTs, it's publishing keys, it's providing an OAuth token exchange endpoint. Why would you want to keep this as a separate piece of software?
So I imagine that an OAuth authorization server might have a bigger role to play outside of your trust domain, whereas a transaction token service is just limited to within your trust domain. So there's sort of that distinction, because of which I believe these two can be different. I mean, there's nothing to stop you from implementing a transaction token like token exchange endpoint inside of your OAuth service. It's just that the two serve very different roles. The OAuth service is going to issue tokens that go outside of your transaction, your trust domain, to your clients or to your API callers and all that. Whereas the transaction token service is minting tokens that are just inside of your trust domain.
I guess I never really make that differentiation personally. I see OAuth tokens used both internally and externally. And having worked in a number of large enterprises, what we found is that consolidation saves money. And if we can use the same approach both internally and externally, we're running less systems, and there's not an exception for an internal service. Or yes, there are different trust differentiations, but am I missing this? Is there something in OAuth that says that OAuth tokens are meant to be consumed outside your domain, and that they're somehow? I never really read that into the spec that OAuth is meant for external.
So I mean, I don't think the OAuth spec has any restriction like that you have to use them outside of your trust. I mean, you can pretty much use them inside. I think the challenge with the OAuth token, using that as a sort of a transaction token to authorize, the context and the identity of the caller inside of your trust domain, is that oftentimes the OAuth tokens have very broad scopes. They have, they don't have a lot of context information in them. And then lastly, they're long lived, right? So you might have tokens that go into hours, days, even weeks, right? And
They can
that,
be long.
right?
Generally, access tokens are generally not long-lived, I guess. But how people actually use it, will vary. Nothing says they can't be long-lived. But I see what you're saying.
Right.
Yeah,
And so what happens is that because of all these reasons, like the breadth of the capability of an OAuth token, the lack of the context information inside of the OAuth token, and the lifetime of that OAuth token, make it like if you're passing that external OAuth token inside of your call chain, a rogue service within your call chain might be able to grab that token, send it out to the attacker, and then that attacker assumes the identity of the user, right? And so now that user can, that attacker can do anything that the user can do, right? So this is exactly what you want to prevent with transaction tokens. You want to not have the ability, you want to have a very narrow scope, you want to have a very set context of what you can do with that particular call, right? And that's why you want to keep these things separate.
Maybe I'm getting a little bit too into the weeds with OAuth, but do you think that we could have done this as an OAuth token grant type? Maybe sort of like a different type of client credential flow, but with additional parameters and with additional claims in the access token?
That's pretty much what we're doing, right? We're
Yeah,
basically sending the inbound context in the form of the access token, in the form of the parameters that you get in the
yeah.
call, to the transaction token service using the token exchange endpoint, right? And then the transaction token service is saying, okay, this is the context, this is the user. Let me mint a token based on my rules, considering this context, and then issue a transaction token that makes sense for my trust domain for this particular call.
So I guess what we're saying is that this by using the token exchange instead of like creating a different grant type, you maybe give the deployer a little more flexibility around maybe having a different, let's say, expiration time for transaction tokens versus access tokens, and maybe some other like special considerations.
Yeah, I mean,
Okay,
typically you'd have your transaction tokens expire in like a couple of minutes, right, or less.
Mm.
So that's kind of what we're talking about here.
Is there any way to do one-time use transaction tokens? Because if I send a wire transfer or an order to buy a stock, I don't want to authorize for 5 minutes. I really just want to authorize for one transaction. Is there any mechanism to do one-time transactions in the transaction token syntax?
So yeah, the couple of things you can do is there's no requirement that all transaction tokens need to have the same lifetime, right? So you might have in your transaction token service, you might have the intelligence that, look, this is the type of call that I want to protect really well. And so I'm going to reduce the transaction token lifetime to like 30 seconds in this particular case. Right? So that's one thing. The other thing is that every transaction token will have a unique sort of JTI value, like which is a unique thing that identifies the whole call chain. And then you can have a settlement service or an execution service that makes sure that the same JTI is not being used again, right, for doing something else, so for another transaction. And so that way you can protect yourself against a replay.
Right. I had Aaron Parecki on maybe 20 episodes ago, and he also mentioned that there's a mechanism called OAuth status lists, because the JTI is a big number, and it's not hard, but it's you're sending a lot of bits around if you have a lot of expirations. And so the OAuth status list defines a new mechanism to take one byte and include an index in the token that specifies where in the status list that token is. Anyway, that might be a more efficient way, perhaps, to expire these transaction tokens than than doing it somewhere in the back end. Have you looked at that?
Right.
Yeah.
Sorry, go ahead.
Well, let's move on. So, in that episode I mentioned with Peter Kasselman and Evan, we were also talking about whimsy. And I have to say, maybe you have the same feeling. I wonder why why do we need whimsy? And how does whimsy relate to transaction tokens? Are they complementary? And I guess, why don't we see the client as a piece of software? And do you see yourselves maybe adjusting with the introduction of new whimsy standards to some of this innovation?
Yeah, and so I think that's a great question, because whimsy kind of came a little bit later than our work in the transaction token stuff. We started, I guess, in 21. No, actually, maybe 22 on the transaction token draft. And at that time, we had this informal working group called, RPC Security Working Group, right? And we were figuring out what to do with it. We decided let's make it a part of OAuth, and instead of sort of trying to create a new working group of sorts. And that included these couple of standards. One is the transaction token standard, and the other one is the identity chaining standard, right? I don't know if you've heard about that one. So both these things are kind of overlapping with what Whimsy has in its charter, but it's just that Whimsy came a little bit later, and so we were already working on this in the OAuth working group. And I'll let it sort of let the sort of working group co-chairs and the area directors and all that figure out where this stuff fits. I think I'm excited about having these as being standards that people can use. I think where these sit, whether it's in Whimsy or OAuth, is something that I'm not terribly sensitive to. I just feel like we've already made a good bit of progress right now with transaction tokens and OAuth, and so moving that right now might cause some disruption. I wouldn't want that. In terms of the charter and in terms of the overlap and all that, I think there are some complementary specs in the Whimsy group that actually refer to the transaction tokens draft. So I think that what they're building is something which subsumes some of the work that we're doing in transaction tokens. So what we're doing is probably very specific, and they have a more generic charter.
But transactions token itself is only in draft 3. So it's relatively new also. So it's not like transaction token's been around for like 10 years. It's not even final yet. What do you see the trajectory? I'm not an IETF expert. I've never been to a meeting. I just crashed the dinners actually. Um, but what do you see as the trajectory, or what do you predict, I guess, in terms of comments and revisions? And when do you think we'll see an RFC for transaction tokens?
Yeah, so the hope is that in Dublin we'll have a sort of, we would have settled all the major issues, right? So we've
Is
had,
that fall of this year, Dublin?
yeah, Dublin is in November this year, right?
Okay,
So
yeah.
this is IETF 121, I think, is in Dublin. And that is when we would expect the transaction tokens draft to be relatively stable. There are a bunch of issues right now that we're working on which are relatively minor. So in what we've seen since draft 1, draft 2, and draft 3 is the quality, or the sort of the, the impactfulness of the issues that have come up has gone down significantly. And so I was
Mhm.
hoping that, sometime after the Dublin meeting, we should be able to get into last call, which is the last step before we make it into an RFC. So I would expect sometime in 2025 to see an RFC of transaction tokens.
So one of the interesting properties that you allude to in the spec, and also in the great talk that you gave for KubeCon, which is referenced for anyone who hasn't done their homework, go see the wiki page. Every episode has a wiki page, and we link it there. But you talk about this very interesting potential property called the ability to immutably assert to downstream workloads that they were invoked in the call chain of the request. So the idea is, as I understand it at least, that as this transaction token is presented, perhaps a downstream service could maybe add something to it and sign it and pass it down. And I don't know if that's currently there or if it's something that you envision, but what was the motivation for that, and how do you see that today?
Yeah, so I think this is something that, again, a lot of the large tech companies actually already have infrastructure to assert the sort of the involvement of certain services in the call chain. And
Hmm.
so, for example, in going back to that stock trading example, right? So if a settlement service wants to make sure that the fraud detection service has already processed this particular call that they're about to execute, that's something that they might need, right? And so initially we went through a couple of different ways in which we could do this using transaction tokens. The one that we've arrived on is that because you may have, let's say 6 or 7 services in your call chain, and then you may just want just one of those services to be able to assert their identity in the call chain. And then they also might not be sequential, right? So a service A may call service B and then may call, service C, right? So, but C needs to know that B has seen this particular transaction, right?
Hmm.
And so what we've done is we've created this thing called as a replacement transaction token, right? So certain services in your call chain will be authorized to get a replacement. And then what happens in that case is that services ID, like if you're using Spiffy, the SWID, is going to get into the transaction token, fields, right? So any service that receives that transaction token afterwards is going to see the transaction token with the SWID or with the ID of the service that requested the replacement, and so it's going to know that that service was in the call chain.
So let me just make sure I have this right. So service A calls service B. Service B then takes a transaction token and makes its own token exchange request.
Yes.
Um, and then a new transaction token is minted that sort of adds service B
Yeah.
into the call chain, and
Yeah.
then returns it back to service A, which then uses it to make the call to service C. I have it
Correct.
right? Yeah.
Yes.
Okay. Um, it's interesting. I like the way you're calling it sort of a chain of trust that enables you to give um, more visibility to what happened. And what are some of the you mentioned? What are some of the real world use cases where you might need to do that?
Like I explained, you might want a service that is doing a sensitive operation like settling a trade. They might say that, look, for me to do this, I need to make sure that the fraud service has actually processed and okayed this particular transaction.
I
Right?
see.
And so if the transaction token tells you, yeah, the fraud service is one of the services that has seen this, and it might actually in the replacement request add an assurance level to that transaction saying this is a high assurance transaction or something like that. And that is what is needed for the settlement service to actually execute the trade, right? And it might do
So,
that only for trades that have a certain, quantity or dollar value or something like that.
so it's not just that the service is getting added into the chain, but also that this service A might actually add additional claims into the token, and then add additional context.
Yeah, service B in our previous example, yes.
I'm sorry, service B, right?
Yeah.
Okay, interesting. Um, and maybe I'm getting a little ahead of ourselves, but today Signal announced a new open source platform called Trateria. I haven't even had time to read the press release, but maybe could you tell us a little bit about this? And I think it's related to transaction tokens.
Yes. So transaction tokens is colloquially called TRATs, right? And so Trateria is a service, yeah. So TRATs, right? TRATs. And so Trateria is a service that basically provides an open source framework for issuance and verification of transaction tokens. And so what it does is it provides a Kubernetes native framework that has sidecar agents that will go into every Kubernetes pod, and it will basically be able to verify the contents of your call against the content of the transaction token, so that if you have the same parameters as what is in the transaction token, they're verified to be exactly what is in the transaction token. And so you cannot basically mutate the calls in the call chain after using Trateria. It's a very simple way of adopting transaction tokens. And so we just released it today in V1. It's like very, very new. And so, feel free to check it out at trateria.io, right? So, it's something that, I hope people will like, and they'll be able to adopt transaction tokens really easily in their existing applications using Trateria. And it's completely open source, so feel free to do whatever you want with it.
So let me make sure I understand this. You're saying that so if I'm an API gateway and I want to use, or there's an application, an API gateway, and a backend service, which of those components ends up calling Trateria?
So the API gateway will call Trateria to mint the token, and then the backend services will use Trateria to verify the content of their calls, right? So let's take an example where you have an API gateway, a microservice A, and a microservice B that is being called, right? Subsequent to that. What you'll do with Trateria is you'll specify to Trateria that, look, this is how you mint the token, and this is how you verify it at service A and service B, right? And so what will happen is Trateria will inject sidecar agents into service A and service B, and it will intercept the calls coming from the API gateway or from service A to service B, right? And so what will happen is you will basically be able to tell to the API gateway, okay, here's your transaction token for this particular API that you're calling. It has all the context and the identity embedded in it. Now, when API gateway calls service A is able to verify that the call parameters and the context is exactly how it's described in the transaction token. And then when service A calls service B, it needs to put the transaction token in the header. We can't do that automatically. But once it does that, service B is able to verify that its context is preserved in the transaction token, right? So it doesn't actually, you cannot modify the content of the call anywhere in the call chain.
I see. And does Trateria have any hooks to policy enforcement?
Right. So great question. And that's sort of why Signal is doing this, is right, because we are a policy sort of a company that offers a platform that enforces authorization, right? And so what Trateria does is it calls out to, there's a new standard in the OpenID Foundation called authzen, right? And so authzen publishes an API for authorization. And so what Triteria does is before it implements or before it mints a transaction token for any incoming request, it's going to call the authzen provider, and then it's going to verify that indeed that transaction token should be minted, right? So for example, like if you have a situation where the user's session has been terminated, let's say using something like CAEP, then the authzen provider might say, oh, I have a session revocation request for this particular user, and so I'm not going to let this go through because the incoming token that I see is older than when I received the session revocation, right? And so this is an old session, and I'm not going to allow it. So that's the kind of policy enforcement that the Triteria service can do via authzen. So it's completely standards based. It's not like tied to Signal in any way, but Signal hopes to be one of the providers that offers authzen as an API so that you can enforce policy at the time of, when you're processing your call chain.
Authzen is very. I heard that standard is very new and maybe a little unstable. Um, what um, what is your expectation around timing for that? Is it mature enough for you to use it today for that purpose, or is there a backup for you to use some mechanism other than authzen?
Right. So I think it's very new, like you said, it's not stable, but that's what we have right now, right? And so one of the things that you get with Triteria is that you're somewhat insulated from those changes because Triteria can make those changes for you. Like if you get a new version of Triteria, it's going to call a new version of authzen if it's there. And so you should be relatively insulated from all those changes in authzen by just using Triteria.
Interesting. Cool. And well, the title of the episode was Securing Identity and Context in Microservices. And so can you talk a little bit more about and relate this back, I guess, full circle into, so now I'm a microservices developer. What should I think about all this? And, your average microservices developer, they conflate ID tokens and access tokens, and now we're introducing transaction tokens. So what do you think the impact is, and what do we have to do to educate microservices developers on how to use this, and also the deployment architecture people who are deploying the API gateways, or what is the workload that we have cut out for ourselves if we want to see adoption of this?
Right. So yeah, I mean, if you look at the OWASP cheat sheet on microservices, you'll see a number of anti-patterns, like about not sending the ID token, through the call chain and things like that, right? And so microservices developers can now have an additional tool by which they can secure their microservices call chains without having to go into these anti-patterns, like just either blindly trusting the caller or being able to pass like long-lived ID tokens that can be abused later. So it actually provides a very good mechanism by which you can just adopt Triteria or transaction tokens by some other means, and you can be assured that the identity and context in your call chains are preserved and secure. Whereas you're not doing something that is insecure, right? Like passing an ID token around or something like that. So did I answer your question?
I think so. And yeah, I had a follow-up question, but so you mentioned that you're getting some feedback in the real world that helped you flesh out the major issues with version 1 and version 2. What have been some, or can you talk about any of the real world deployments of transaction tokens, and what have you learned along the way?
Right. So what we've learned is that there are a number of large tech companies that use something similar. They're not using transaction tokens because the draft is like very new and it wasn't around when those implementations existed, right? What I do know is that something very similar, like something which has the same properties as transaction tokens, it doesn't have the same format or so, but it has the same sort of architecture, is deployed in tens of thousands of microservices at large tech companies. right? I can attest to that because of sort of the feedback that we're getting after we've published these drafts, right? And so yeah, it's an architectural pattern that seems to be making sense. It's something certainly at a previous employer I have seen in practice, and I had never had to think about it. And it's only when I was not working there anymore I found out that, oh my God, we need something like this that everybody can use, right? And that's how we came about with this. So yeah, I think there's a lot of previous work that transaction tokens depends on and it leverages in order to sort of provide this draft. The hope with this draft is that API gateways will just bake this into them, and you don't have to actually think about it when you're implementing your microservices. You just will be assured the identity and context as you develop those microservices. So it's not something that you have to worry about. Is the hope.
So Triteria is open source, and what's the monetization strategy, and what's sort of the enterprise features for Signal? Like, what's the hook for? We know it's. I see Signal doing a lot of open source and open standard stuff, but all that stuff's non-differentiated. What's the differentiator in there and the business value that Signal's offering?
Right. So this whole area of non-human identities, right, of which transaction tokens is a part, right? I think it's very new, right? We are still sort of figuring out what we should be doing there, and it's okay for us to say that, look, let's just do this. This is the right thing to do, and let's not worry about how we're going to make money on this. The obvious thing that we have done in Triteria that helps Signal is we have the auth hook, which allows us to enforce policy at the transaction token level, but even that is based on standard. You can have your own auth provider and you can not use Signal. We think that at this time the industry is in a stage where having that security is more important than sort of deciding, okay, how is Signal going to make money out of this, right? But I feel like going forward, I'm sure there will be ways in which we can maybe offer some differentiated services on top of Triteria, like excellent policy management, things like CAEP, session revocation, or other capabilities using CAEP could be things that we can help in transaction tokens.
So I see that we have actually quite a bit of chat. So audience, I'm sorry, I can't read the chat and pay attention to my guests at the same time, but I would encourage everybody after the episode, we can keep the chat going so we can pick up the conversation there. Before we stop for the day, Atul, any last thoughts?
Well, I mean, thanks very much for having me here. And, it's been an exciting time for me with Signal. We are providing sort of zero standing privilege, and, transaction tokens is a part of that, where, no one should have access to, standing access to critical systems unless they have a specific reason why, currently they need access, like, for example, to AWS or anything that you have. And so tying this back to transaction tokens is the same thing, that when you're executing a API call, why is this caller, does this call need access to the specific data that is embodied in the call? Like, if you see OWASP, the top thing that OWASP has in API access control is object level access control. And this is the kind of thing that can offer that in combination with Signal. So that's kind of how I hope we'll be able to secure enterprise environments in the future.
And, in the last episode, we had Mark Borstein and Alex Sierra, two of your fellow KubeCon speakers in that from the last KubeCon. And we talked about the confused deputy problem, where basically one service has more access than another service and is used to, we trick that service into doing something that the user didn't originally have authorization for. So I think a lot of those OWASP IAM vulnerabilities we are talking about are a result of that, where we're trusting this thing, but we shouldn't trust it as much. So I do think that is really that is the main challenge, right we're facing today.
And
Well,
transaction tokens are a solution to that. So
agreed. Yeah. Atul, thank you so much for joining us today. It was great
Yeah,
having
thanks
you.
for having me. Great talking to you.
And to the audience, I'll encourage everybody, please follow Identity Office Hours on LinkedIn. We're trying to get to 1,000 followers. Next week, we actually have me as the guest. I'm presenting Cedarling, which is a new piece of software that we're writing for authorization. So please join us. Well, Kevin Campman is going to be the skeptical co-host and ask some hard questions. So thank you, audience, for joining. Thank you, Atul, and we'll see you on Thursday.
Thanks, Mike. Great time.